Hello, I'm JW. Today continuing in the heating series, and this time we're going to look at combination boilers and attaching thermostats to them. Now I've already done several videos on heating, so if you've got a different type of system then probably already got a video covering that, and links to that are in the usual places. But so today we're going to look at combination boilers and say connecting a thermostat to them, and of course that may involve removing an existing thermostat if you already have one, or possibly just fitting one in for the first time if you had some rubbish install where someone couldn't be bothered to fit one in the first place. Now before we get into the actual connections and whatever, just have a look at what a combination boiler actually is. And it's basically a box which fixes on the wall, usually gas powered, although of course can be oil as well, and you can even get useless electric versions if you really wanted such a thing. And the point about this is that it's got coming in the bottom a cold water supply. That's usually the mains pressure coming in from the street, and coming out of there is a hot water supply, and that's the one that would go to your actual hot outlets. So there's your hot outlet in the bathroom or the kitchen or wherever else, and the deal is that when you turn on the tap here, then water will flow through. It detects that the water's flowing, and then it attempts to heat up the water on demand. So there are no hot water cylinder, so simply don't have one of those. Now the word combination also implies that it can do other stuff, and typically we're going to do your central heating radiators. So you will have two other pipes coming out of here, and those will go over to your radiators to actually heat up your house. So it has the two functions in one of which is to heat your actual radiators, which is a sealed circuit or sealed loop of water there, and then the actual hot water part, which is completely separate inside, but it uses the same fuel of course to do the heating. So a combination boiler there, so no hot water cylinder, and of course as well as no cylinder, then you will not have any things like zone valves, because of course there's only the heating coming out there. In theory you can have more than one heating zone, but typically it's not something going to happen. So it all basically wires back to the boiler itself. Now this type of boiler should only be fitted in small properties where there's a small requirement of hot water, but unfortunately plenty of people fit them in 3, 4 and 5 bedroom houses and with 2 or 3 bathrooms, and of course they don't work there because the thing can only basically supply one outlet at a time. But nevertheless these things are fairly popular, and essentially for most combination boilers the only controls you're going to want will just be for the actual heating part. There's no controls for the hot water because it's simply a case of when you turn on the tap here, then the boiler turns on and heats it, and when you turn the tap off, then of course the boiler switches off. So it's only for heating, and if you're going to be buying things like programmers or timers or whatever, then the one you want to be getting is a single channel model. So don't do one thing obviously on there, and of course the single thing is of course just to control your radiators and heating. Now thermostat, as we've seen in several other videos, is a device which senses the temperature of the air, and then it will turn the boiler on and off as required. And for a combination boiler, in fact most other types, the simplest form is just going to be 2 contacts inside, and then between those will be some kind of switch, and these 2 wires here would connect to the boiler in this case, and the rest of the system if it was a more involved heating system. And all that happens here is that when the temperature of the room is hot and you don't need any heat, then the switch is open like that, and then when the room temperature falls below the thing you've set, all that happens is this contact inside will move and connect the 2 wires together, and then the boiler will switch on and heat the rooms. And then of course when it gets to the temperature you've set, then the contact will open, breaking the circuit, and then of course the boiler will switch off. Now of course you can get many types of thermostats, ranging from the most simple mechanical thing on the wall, costs about £10 or less, to the latest model of some internet connected piece which you can control with your phone and when you're on holiday in Australia and all that business. But regardless of what it is, ultimately it is just a switch which is either on or off, and that determines whether the boiler is on or off. So in terms of wiring them in, it's pretty much the same, although some of course may have all those other features included, but it basically comes down to just a switch inside. Now another term you're going to come across in terms of thermostats, particularly for combination boilers, is volt-free contacts. And all this means is that you've got a thermostat, as we had a moment ago there. It's got some kind of switch inside, and it's got the coloured wires and things coming out to the outside world. Volt-free contacts means exactly what it says. It means that the actual contacts inside the thermostat, as in the two wires you're going to connect to, do not have any voltage on them. It is purely just a switch inside which either joins them together or does not. So in its default state there's no voltage there. Of course, when you connect this to the boiler there's probably going to be some kind of voltage supplied here, but crucially the thing itself does not have any voltage on there. And this is important because a lot of combination boilers require this type of arrangement, because essentially you're just connecting two wires inside the boiler together. The boiler itself is going to provide whatever voltage or whatever goes through those. You definitely don't want to be putting voltage onto those. Now compare this with a mains voltage thermostat or mains voltage switching, which is typically used on other heating systems, the type where you would have a hot water cylinder and various other bits and pieces, zone valves and so on. Those are typically rated at mains voltage or 230 volts. Now this is a typical sort of arrangement. They may well have additional terminals in this case. So we've got line, switch line and neutral. So essentially what you would do is connect to the line, that would be your 230 volts there. And of course neutral is going to the neutral connection. So that's powered all the time. And then the switch line output, when the contact closes, basically you're going to get 230 volts out on that terminal there. And again, when it's open, you basically don't get anything. And crucially on these ones, the output here for the switch line, it goes back to the rest of the system. When it's actually on, you will actually get 230 volts coming out of there. And this is a huge problem with some combination boilers, because plenty of combination boilers will be destroyed if you shove 230 volts into the thermostat contacts. And essentially what they will do is destroy the printed circuit board inside the boiler. You're then going to have a new one fitted. They cost hundreds of pounds each to buy, and it will also cost you hundreds of pounds to have it installed and the boiler set up and so on to go with it. So connecting 230 volts to the wrong terminals in a combination boiler is a serious blunder, and it's one that would cost you many hundreds of pounds to fix. So definitely want to be avoiding that. Now some combination boilers do have 230 volt contacts, so that's perfectly fine in that case. Plenty of others only have what's called the volt-free one, so it expects just literally a switch outside, no voltage being shoved in. And even more confusingly, there are certain combination boilers which have both sets of contacts, so you can use one or the other. But again, certainly not both, and you definitely don't want to get the two mixed up by mistake, as that's going to be a very costly error to make. So let's have a look at the actual wiring and how you would connect these things to a boiler. Now the most simple kind of thermostat is the one we've got here, which is basically just two connections, labelled here line and switch line. And when heat is required, the contacts are connected together, so those two are connected. And when it's not required, of course, they are not connected. And the contact will just move across like that and join them together. But in the case of this one, it doesn't have to be line and switch line. If you were doing on a 230 volt system, then of course it would be line and switch line. But if it's a boiler with those other voltages inside, then of course it could just as easily be A and B, or in fact any kind of combination of things you wanted. And the important thing with these ones is that if you're going to connect it to the two terminals in the boiler, it doesn't matter which way around these things are connected, because after all it is only just connecting two wires together. So if the terminals in the boiler were say called A and B, you could connect A and B in the same way round, or you can connect B to A and whatever as well, because say it doesn't actually make any difference at all. Now the other type of thermostat is this one, which this is typically going to be an older style of thermostat found in considerably older systems. These are not volt-free contacts because these do require mains voltage to operate, and this is basically the line coming in at the bottom there, switch line going out when the heat is required, and then additionally it needs a neutral connection, and it's got that accelerator resistor or little heater inside the thermostat so that it reacts to the room temperature at a decent kind of rate. So you typically only find these on very old systems. This is not the kind of thing you would be fitting on a new system, because they're quite slow to react even with that accelerator heater in there. And most importantly, they only work properly when they're used at mains voltage or 230 volts. Although in theory you could just connect L and SL to a boiler that say didn't have a 230 volt input. The problem then is that the accelerator heater isn't going to work, and all you'll find then is that the thing will turn on and off, but its response to the room temperature will be horribly slow. It'll literally take forever to actually do anything, and it'll be pretty much a waste of time having it. So if you've got one of these older type of thermostats and you're having a new combination boiler fitted or whatever, then in reality you need to get rid of this thermostat because it's not really suitable for use with the combination boiler. Now what we've got here is a more likely scenario for a modern thermostat, And again, these are going to be the volt-free contacts, which we've got labelled A and B here, because there's no voltage being applied to the contacts. The only voltage on those is going to be what comes from the boiler itself. And this one has a connection for mains power, as in line and neutral at the bottom there, and this is to actually power some electronics, basically a timer, inside the thermostat itself. And this is the kind of setup you would typically find with a programmable thermostat, as you can set the time and the temperature, and also the wireless type of thermostats where you have a separate box which attaches to the boiler, and then the actual thermostat or the temperature part is mounted somewhere else and is battery powered. Of course, links to this piece via a radio remote control. So what we've got here then, the line and neutral requires a permanent supply, and you would take that from the boiler itself, and that's just purely to power the electronics and the radio transmitter and whatever inside. And then the contact A and B again are just connected together when heat is needed, and of course not when heat is not. So again, volt-free contacts, and fairly common if you're going to have one of those sort of radio remote or wireless thermostats. Now a slight variation on that is the same kind of connections there to the boiler, the A and the B, but the electronics inside are actually powered from a battery, and this will be the case if you have a wired thermostat, again probably in the same lines with a programmable thing, so you can do the time and the temperature and whatever. But in this case, instead of having a box next to the boiler and then the sensing part somewhere else, you would just have a cable from the boiler to wherever you'd mounted the thermostat, and the thermostat again is powered by a battery. Again, there's no main voltage connections here, it's just the two wires to the boiler, which again we've marked as A and B here. Only disadvantage of this one, of course, is you have to put cables to the thermostat position, which of course may not be appropriate if it's a refit in an existing building, but the wiring is going to be the same, and they say you just need to put batteries in the thing to make it operate. Now when you actually get to connecting it to the boiler, the simplest possible arrangement is going to be what we have here. Now all combination boilers require a main supply, and this does need to be on permanently, because of course if it's not on, then when you turn on the hot tap you won't get any hot water. And typically this is going to be provided from a 3 amp fused spur or fused connection unit, and you've got the 3 wires there, line, neutral and earth, which just go straight into the boiler. And that 3 amp fused spur is important because it provides a point of isolation for the actual boiler, and you're going to be needing that when the boiler is going to be repaired or serviced or whatever else. Typically it's just going to be mounted right next to the boiler itself. As we saw before, the connections to the thermostat are simply 2 wires, A and B in this case, but can have other names, and those just go to the 2 connections in the thermostat. Now when you actually buy a boiler and it's fitted in for the first time, as supplied from the factory there will be a wire link installed between the 2 terminals in the boiler, and that's only there for testing purposes, so that when the boiler is actually switched on for the first time and is set up and obviously checked for proper operation, you can have the thing actually working without the need to wire up any outside controls. So if you're fitting one on a boiler for the first time, then any link between those terminals, in this case A and B, you need to remove that link, and then of course connect the thermostat to those terminals instead. And bearing in mind the thermostat's only doing what the wire link would do, it's just obviously removing and replacing that link effectively as the temperature changes. Here we have a similar arrangement. This will be one of those battery powered thermostats, sort of a smart or programmable thing, and again the wiring is exactly the same, it's just the 2 connections in the boiler go to the 2 connections on the thermostat, and this is a battery powered device, and simply put the battery in there to power the thing, and it just opens and closes the contact as required. Now if you've got a wireless thermostat, and this also covers things like the Nest and the Hive and all those overpriced fancy items, then the receiver box, which goes next to the boiler, will need to have a main supply to it, and of course that's what actually powers the thing. But the actual thermostat part you put on the wall will typically be battery powered, and of course that connects wirelessly to the box on the wall there. So you've got the same 2 wires there, A and B, which go to the thermostat contact inside, and then additionally it needs a power supply on the line and neutral, and it's absolutely essential that this power supply also comes from the boiler. So again, when you turn off that fuse spur there, it also turns off the actual thermostat receiver as well. So you need 2 cables for this, one for the power supply to the thermostat, and then the other 2 of course are the actual contact which does the switching on and off. Now there are a few other combinations, although these are going to be less likely, certainly on newer installations. And what we've got here is a basic thermostat, but this is actually switching at mains voltage. And you can see it's the same 2 connections to the thermostat, but the 2 in the boiler are slightly different. We've got one connected to the line, and then the other one goes to a switched line. So essentially it's just applying the 230 volts to the switch line when the heating is required. And again, when it's not required, then it's not connected. So in this case we've got the two wires both going onto the line terminal. Some boilers inside do have additional line terminals, so you can avoid having several wires into the same one, but the actual connection of course is the same. The only thing to be careful of here is that the thermostat you're using is suitable to use at 230 volts. The vast majority are, but do check beforehand, because of course if it wasn't, that could be a dangerous situation. And if you have a boiler which does use the mains voltage switching, and for some reason you had one of those old manky thermostats from 40 years ago with an accelerator resistor inside, then theoretically you could connect it up to the boiler like this. So you've got permanent line and neutral going over to the thermostat, and then again the switch line comes back to the boiler, and again this is mains voltage switching. So again, this is only suitable for boilers that have mains voltage switching as an option, and also if you really wanted one of those old type twisty dials on the wall with the accelerator resistor inside, which let's say, as I said before, you almost certainly would not. But if you were desperate to save a £5 or £10 or whatever because you couldn't be bothered to buy a new thermostat, well, this could be the option for you. Now, so if you're going to be fitting a new thermostat, it's almost certainly going to be one of those programmable types, so you can set in both the time and the temperature you want, so there's only a single device to deal with. If for some reason you wanted a separate timer and a separate thermostat, as will be used on much older systems, then you can still install those, and you're going to have the wiring in the similar arrangement to what we've got here. So we've basically got here is a programmer or timer, and then the thermostat as well, and essentially wiring the two things in series, so that the boiler only operates when both the timer is on and the thermostat is on as well. And we can see there at the left side we've got the power going to the programmer. Again, that's just your standard 230 volt mains going in, and then the switch in the timer goes through the terminals there. We've got 2 and 4 connected in this case, and then from that you go on to the thermostat and eventually back to the switch line for the boiler. And all that will happen here is that when the actual programmer is on, then the switch will move across like that, and then of course you've got mains voltage going all the way through there to the thermostat, and then when the thermostat is switched on, of course the power then goes through to the boiler, and the boiler will switch on and heat your rooms. And if either or both of them are turned off, either because the timer has got to the set period or the room's got too hot, then again the boiler will turn off. Now when it comes to actually using real thermostats, there's a couple of common examples. Now what we've got here is the Hive wiring, and this Hive comes in two versions, the single channel and the dual channel. As we saw previously, you want the single channel for a combination boiler because you're only dealing with turning the heating on and off. The dual channel one is not really suitable because, as well as having hot water functions which you wouldn't need, the dual channel one is actually a mains voltage switching item, so unless your boiler has mains voltage options for switching, you can't use it. So ideally you want to get the single channel obviously, and as with most of these it has the volt-free contacts. Now as we saw in the diagram there, this requires a permanent supply, and we've got the line and neutral there on the L and N terminals over to the left. And the terminals for use here, they've got a common heating off and a heating on, and the two terminals out of this we want is the common and of course the heating on. In theory you could use a heating off for some other function, but as we've seen previously, it's just a question of connecting two things together. So common and heating on, or 1 and 3 in this case, heating off is not required, and in this case terminal 4 isn't actually used either. So this would represent, say, the actual receiver box that goes on the wall, and then the actual user thermostat thing would go on the wall in some other part of the building. And this type of backplate is fairly standard, and as well as being used for the Hive thing we've got here, it also is used for a whole load of other thermostats from other manufacturers, and the wiring is usually exactly the same inside. So say just two wires to the actual terminals for the control, which is 1 and 3, and then your main supply to the line neutral, and you've got that earth terminal down towards the bottom right as well. Now the other more common item which people don't spend huge amounts of money on is the Nest thermostat, and because this is some foreign device which was not designed really for use in the UK, it has terminals in a rather more unhelpful arrangement, but the actual principles are pretty much the same. On the left side there we've got the terminals for line and neutral, so as it says there, that's your 230 volt power, and that needs to come, say, from the boiler and needs to be on permanently. And then for the actual heating, again we've got those three terminals there. We've got satisfied, common and call for heat, and the ones we want for that are going to be the common and the call for heat, or as it says there, normally open, so those are the ones which would be connected together when heating is required, so 2 and 3. And again it does have the satisfied or the heating not required terminal, but again that's not going to use on a combination boiler. And although this has the hot water things as well, again you wouldn't be using that on a Combi boiler. So again, the wiring is pretty much going to be the same. It's just that in this case the terminals are in a completely different order, and they're also permanently attached to the device rather than a plate which you can wire up and then attach the thing to later. And these are volt-free terminals, so again no problem using it with a combination boiler. And the final part of this video is how do you find out which terminals in the boiler are the ones you need to use? Well, of course the answer is very straightforward. You go to the manufacturer's website of the particular boiler that you have, and you download the installation instructions. And note you need the installation instructions, not the user instructions, because the user instructions tell you nothing. So installation or servicing instructions is what you want. And be sure to get the correct one for your model of boiler, because most manufacturers make huge numbers of different boilers. Of course they may have different connections inside. Now this particular one is for a Worcester boiler, and as we can see on the front there it just tells you the make and model and whatever. And then somewhere inside the manual, which in this case is on this page here, it will show you which terminals are for what. So inside here then we've got the terminals shown there at the top left, and we see that the items marked 13, as it says there in the table below, is the boiler 230 volt main supply, so you connect your line, neutral and earth to those 3 terminals over there. And then the 2 terminals for the heating are the ones towards the left side, and we can see there it's actually the ones on the 8 and 9 terminals. In this case it's actually the link that goes between the L and the little symbol there for a radiator, which is marked LR. And you'll see that it's got the little link above it as well, so that's the link you would actually remove, and then you just connect your actual thermostat wires to the LR and the L terminals. And so it's all detailed in the table below, so again there's no real problem about that. And if you look in the part where it says number 8, it says 230 volt AC switch live inputs. The CH1, or the one with the radiator, is the external central heating control. And note that this particular one is a mains voltage switching, so again obviously you can use that with either type of thermostat. Now here's another example. This is a Vocera boiler, and again very similar arrangement for the connections there. See the top diagram there is figure 6, and we've got inside the first cable there coming in with the main supply, so the 230 volts, and it goes to the L and N terminals, and also the earth there in sort of the middle on that central strip. And then your room thermostat is the 2 wires which go to the 2 terminals. They're both marked TA in this case. And if you look over to the right there, again it says remove the link between the terminals there before installing the thermostat. And this again is a 230 volt connection thermostat. And as it says also on the right there, if it requires a neutral earth you can connect those to the appropriate terminals as well. Now note that both the terminals are marked the same thing, but as I saw before it doesn't actually matter. All you're doing is connecting them together, so the fact they're both marked TA doesn't make any difference at all. Now here's one for a Ferroli boiler, and again very similar arrangement. We've got the terminals shown there over on the right, and the ones we're looking for in this case are of course the ones on the right side there, which are marked 72, and you can see the key over on the left side there which says room thermostat, and most importantly it says volt free, so you definitely do not want to be putting 230 volts anywhere near those 2 terminals. And as you see, it's already got the little link in place there which you would remove and then attach your thermostat to those 2 terminals. And those not shown on this page, just like the other ones, it also needs a permanent main supply to the boiler itself. And if you look down at the bottom here, it says, caution, the room thermostat must have voltage-free contacts. Connecting 230 volts to the terminals of the time clock and room thermostat will irreparably damage the PCB. So that's where you're going to basically destroy the boiler and have hundreds of pounds to fix it. And finally here we've got a Glowworm example, and there on the right hand side we've got the connections to this. Now this particular boiler has a kind of weird plug arrangement which you basically wire up and then just shove in the bottom of the boiler. You can just see that at the top of the page. Again, the wiring is going to be pretty much the same kind of deal. So the diagram at the bottom right, which is say 11.2, we can see again the permanent power going in, the L, N and E going to the appropriately marked terminals there. It's on the right hand side of the connection. And this particular boiler is one of these that has 2 choices for the thermostat. It can either be a 24 volt one, which is supplied via the boiler, or it can be the mains voltage switching if you actually want that. And have a look on the next page here, it gives us details of which ones are which. So if you wanted to use the 230 volt mains power to switch the thing on and off, then you're basically collecting between L, which again is the incoming terminal, and then the terminal marked R on the right hand side there, and you see it's just that box which says 230 volt AC system controls, or basically the thermostat in this case. So all it's doing there is connecting between the L and R terminals, so 230 volts is shoved into the R terminal and the boiler turns on. However, in this one you can also use the other terminals over to the left there, which are the 0 and the 24 volt items, and it says in the table above 0 volts is the 0 and 24 volts is the low voltage demand. So you could connect a volt-free thermostat between the 0 and 24 there, and again that will do exactly the same job. Important thing here to note is it's only one or the other, and you most definitely don't want to get 230 volts accidentally going into those 24 volt terminals over on the left, because again that will destroy the boiler. And then over the right you can see where the sort of plug just shoves in the bottom of the boiler with the wires and screws in. So that is combination boilers and thermostats. Quite a simple thing really, it's just a question of identifying the correct terminals in the boiler and obviously connecting them to the thermostat as required. And the main key here is not to connect 230 volts to terminals which are not designed for them, because if you do, the boiler is going to be damaged and be very expensive to repair. And in terms of what you can use, say all the thermostats are basically the same. It doesn't matter if it costs £5 or £500. In the end it's just an on and off switch which just connects two wires together. Obviously the more expensive ones you can control with your phone and all that business, but in the end, say, it's just a on and off switch inside. So that's it this time, and until next time, thanks for watching.